Hello and welcome. This is going to be our homework help video for the homework titled Systems of Equations by Graphing. Let's start off with problem number 1 here. What will cause a two-equation system to have no solution? What about infinite solutions? And since we're talking about graphing, I want our answers to be about graphing here. This is what I would write for a problem like this. A system will have no solution if the lines are parallel. The system will have infinite solutions if the lines are coincident. Means are the same line. And I think to kind of help this explanation, we could have a little drawing of parallel lines, two lines that are next to each other, and coincident lines, two lines right on top of each other. All right. Solve each system by graphing. Problem number 2. So when solving by graphing, I want these equations to be in slope-intercept form, but they already are. So if they weren't, that would be my first step. But since they're already in slope-intercept, I can just go ahead and start graphing them. Let's start with this first one. It has a y-intercept at -3. So I put a point at -3. Its slope is 2/3, but I just turn that right into rise over run. From this point, I can go up 2/3. Or I can go back to this point and just reverse both those numbers and go down 2 backwards 3. And you can see it keeps it in a straight line if I do that. Let's connect these up. Make a straight line go across the graph. And there we go. So this line here represents all of the combinations of an x and a y that will make that first equation true. But we're looking for the combination that makes them both true. That's why we have to graph the second one. All right, let's go to its y-intercept of 1. Now its rise over run is 2/3, but look at this negative. This negative could go on top or on bottom. Let's pretend like it goes on top first. If it goes on top, then our rise is -2. So from this point, I need to go down 2. And then my run is 3. 1, 2, 3. But if the negative goes on the bottom, then my rise is +2, and my run is -3, meaning go left 3. Notice that keeps it in a straight line. If we connect these up, we can see a very clear intersection on a lattice point down here at 3, -1. And then we can emphasize our answers by saying x equals 3, y equals -1. All right, let's try a different one. Let's try number 5 here. Same strategy. I'm going to plot the y-intercept of 2 for the first equation. Its slope is 1/2, so I can go up 1/2 to get my next point. You can keep that pattern going until I'm off the graph. Reverse them both. Down 1 backwards 2 takes me off the graph this direction. Connect them up. We got our first line. Next one starts at -4. Its slope is 2, but I can make that a 2/1, so it's easier to graph, meaning go up 2/1. And we can see it closing in on this line. Will it cross it? Yes, it will, right there at that point. Still connect them up just to make it clear what's happening. We need to name this point right here. That is the ordered pair 4, 4. Emphasize our answers are x equals 4, y equals 4. This is the only combination of an x and a y that will make both of these equations true at the same time. Let's look at number 3. Kind of skipped number 3, but looking at it now, I can tell it's going to be a little bit different. If I plot these and go a little bit quicker, point at -1, down 3/2, or up 3 backwards 2, makes my first line. The next one, point at 4, down 3/2, down 3/2, makes my second line. This is one of our special cases. This is a what we call a oh, what is the word for it? It's a no solution because they're parallel. I think it's discontinuous. Let me look at our notes for today. I always forget this word. Oh, inconsistent. That's the word. I don't know why it was escaping me for a second. It's an inconsistent system. Therefore, we have no solution. Don't worry, if I can't remember it, I'm not going to expect you guys to remember it. Just want you to have heard that word a couple times in case you see it. All right, moving on to the back. These ones look pretty similar to what we were doing. Number 9 gets a little bit different with this x equals 4 equation. So that's not in slope-intercept form. So you might think, okay, I've got to turn that into slope-intercept form, but it actually can't be done. You have to remember Hoy-Vux to be able to plot lines like this. Specifically, if it's an x equals equation, we're going to the Vux half of Hoy-Vux, which tells us that this is a vertical line because of the v, because it's an x equals equation. So a vertical line at x equals 4. Another way to think about it is it doesn't matter what y equals, x is always going to equal 4. So I dot in every ordered pair where x is equal to 4, and you can tell I make a vertical line. Now to graph our other one, same system, point at -3, our y-intercept, up 7 over 4. So up 7 over 4 lands us right there. Connect these up, and we can see that they intersect at that point up here in the first quadrant, 4, 4. Emphasize our answers by saying x equals 4, y equals 4. All right, but now what to do about 10 and 11? These aren't in slope-intercept form, so they're more difficult to graph. So my advice is just convert them into slope-intercept form, and they're going to be easier to graph. Let me start by just copying down this top equation. 5x minus 2y equals -4. To get it into slope-intercept form, I got to get y by itself. So this 5x can't be over here, so I'm going to move it to the other side. I'll cancel on this side, and I'll be left with -2y equals, and I put the -5x in front of the -4 to make it look more like mx plus b. Now I divide every term by -2 to get y fully by itself, and I get y equals -5 divided by -2. The negatives cancel out. I get 5 over 2. The x falls off the top of the fraction, goes out in front. -4 divided by -2 is +2. Let's do the same thing for this equation. Bring it down here. So x plus 2y equals -8. I'll move the x to start. 2y equals -x minus 8. Divide everything by 2. We'll get y equals -1/2 x minus 4. All right, and now I've got two equations that I can just graph and find the intersection point. I'll do that real quick, and then we'll be done. First one, y-intercept of 2, slope of 5 over 2. So I go up 5 over 2. Can't be done, so I could also go down 5, backwards 2 to get another point. Connect them up with a straight line. That's our first line. Next one, y-intercept of -4, right there. Slope of -1 over 2, so down 1 over 2, or up 1 backwards 2, hitting that point, our point of intersection. Connect up these 4 points, and then just name the point of intersection as being our solution. Right there is the point -2, -3, or emphasize it as being x equals -2, y equals -3. The only combination that will make both of those equations true at the same time. All right, have a good rest of your day.